Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Cross-Reference by Jobo. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Digits along an arrow must sum to the digit in that arrow's circle. And these are all arrows, right? So it's actually pretty cool. It forms a very cool design here. I like it. It's like a cross. It's like a lattice. But these two digits must add up to what this digit is, right? Because the digits on the arrow sum up to what's in the circle that's connected to the arrow. And this is an arrow because it's hard to see because it looks like a different pattern. This is also an arrow. This is also an arrow. So let's use this one as an example. So if this were a 2 and this were a 5, this would have to be 7 to add up to it, right? Because these two digits must add up to what that is. Actually, this is not correct because of what we'll get to the next clue, which is small clues on top of arrow circles show either the highest or the lowest digit to appear on all arrow line segments attached to that circle. So this 7 is saying there is a 7 and it's on one of these arrows, and it must be either the lowest digit along those arrows or the highest digit. And obviously, if there was a 7 along one of these arrow segments, it could not have a 7 here because that would be 7 plus another digit equaling 7, which is not possible. Another normal Sudoku digit, I should say. You could sometimes occasionally have a 0, but the 0 is not a normal Sudoku digit. Anyways, it could also be that, like, for example, this is a 1. This is saying that there has to be a 1 along one of the line segments, and it has to be the lowest or the highest. Obviously, it would be the lowest digit in any of these segments. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So this says that there's a 7 along one of these segments. And it says that it's the highest it can be. Right? Because you can't have 7 be the lowest. If 7 were the lowest, that means these would have to be at minimum 7 and 7, which is 14, which is not a valid digit. So 7 has to be the highest digit on one of these cells, which means this has to be an 8 or a 9. Similarly, this says that a 7 is the highest digit on one of its segments, and therefore this must be an 8 or a 9. Now the thing is, we have now an 8-9, 8-9 pair in column 5, so this can never be 8 or 9. So this could be 7, but it says we have a 4 somewhere along these segments. Well, if 4 were the lowest, the problem is then this would have to be 4 and 5 together, which would be a 9, and that's not allowed. So 4 has to be the highest digit possible. Therefore, we know these are 1 through 4, and these must be 1 through 4, because this can only be 7 at most. So this has to be 5, 6, or 7, because it's 4, 1 at least, right? Because we know there's a 4 along one of the arrows. 1 obviously has to be one of the lowest ones here, but we don't have any other information there. Similarly, 1 has to be one of the lowest here. This has a 5 as its number. Well, 5 cannot be the lowest number because if 5 were the lowest number, it would be 5 and 6. So therefore, 5 is the highest number in the arrow. So this is 1 through 5. Which means this is at least 6. So this is 6, 7, 8, or 9. This could be either way. It could be 1, 2, as 2 is the highest digit, or it could be 2 as the lowest digit, and it could be with 2, 7, 2, 6, 2, 5, 2, 4, 2, 3. So this one's not very restricted right now. This says there is a 3. Oh, okay, that's actually one thing. We know one of these is 3. We know one of these is a 2. We know one of these is a 2. And one of these is a 5. Because they only are in one of those two cells. So then this has to be at least a 4. It's 4 through 9. Because 3 could be the lowest or 3 could be the highest. We're not sure which. Um, Interesting. So this could actually be the 7. Hmm. One of these, well, no, this could be the 7. We don't know. Hmm. These digits have to be 2 apart from each other. Because this is the same digits, and these digits, sorry, 1 apart from each other. Because this is the same digit, this has to be 1 apart from each other also. Since this is 1 through 5, to add up to 8, it would have to be 7 through 3. Similarly, this would have to be 7 through 3 to add up to 8. If it's 9, it would have to be add an 8 also, right? And then this would be 4 through 8, 4 through 8. Um, hmm. Hmm. What else do we know? Okay, so we know the rest of the cells in column. Hmm. That's not that helpful. Oh, this can't. Well, no, it could be either. That's fine. Hmm. Hmm. How do these interconnect? I'm not really sure. Um. Hmm. Oh, this can never be 8. Oh. This can never be 8. This can never be 8. So this can never be 1 here, right? If this were 1, one of these would have to be 8 to add up to 9. But we know that 8 can never be on this segment, right? Because 7 is the highest. 7 can never be the lowest digit. So this is 1 through 7 also. This is 1 through 7. These are 1 through 7, 1 through 7, and 1 through 7. 8 can never be in either of these cells. 9 can never be in either of these cells. Therefore, 8 and 9 both have to be in these cells. So this has to be 3 through 7, and this is 3 through 7, right? The reason why we know is 8 and 9 cannot be in the remaining cells in column 5 because of the 8-9 pair. So these can't be 8 or 9. Obviously, these can't be 8 or 9 because specifically 7 is the highest digit it sees. So therefore, 8 or 9 has to be along this one of these 3 cells, which eliminates 8 and 9 from these 2 remaining cells. Okay. Because of that, these cannot have, these has to be at most 6. This is at most 6, and this is at most 6. Therefore, this can never be 1 again, because if this is 1, this would have to have a 7 and an 8 to be next to it, and that's not possible here. So this can't be 1. Similarly, this can't be 1. Actually, none of these could be 1, right? Because, well, this one could be. These 2 could be, but these specific ones cannot be 1, because if this were 1, then it would have to have an 8 essentially be added to it to add up to 9, because one of these would be 9. Therefore, one of these would have to be 8. But these could be 1 because it could be 1 and 7 added up to 8, because this is not guaranteed to be specifically a 9. One of them does, in these 2 cells, does have to be a 9, though. That's actually very interesting. If that were the case, if this were 3, this would have to be 1. This would be 2. This would then be 1. This would be 2. So that seems feasible still. Huh. Oh, this can never be 7 anymore. Okay, that fits that. It's because this is always less than this digit. So this can never be a 6 either, because these two have to add up to whatever this digit is. And if this were 2 and this were 6, it would add up to 8. Because 1 can never be here. Therefore, we know 7 has to be one of these 2 cells. Because these cannot be 7 anymore. So one of these 2 cells is a 7. Aha! And since one of these 2 cells is a 7, it can only be now with 2. So then this has to be 9. And one of these is 7 added up to 2. This must be an 8 then. Which means this can't be 8, this can't be 8. So the 8 can only add up with 7 with 1, right? And one of these 4 is a 7. We're not sure which. And the 7 must be with a 1 because it adds up. So this cannot be 7. So this is the higher one because this is the higher digit and these are the higher digits. So this can never be 1. This can't be 2 because it can't. This one of these is 7, and this can't be 7 specifically. So these add up to 9. This can never be 7, and this can never be 7 or 6. No, it could be 6. Cannot be 1 though. Therefore, this can never be 7. So both of these have to be 7, which means one of these has to be a 1. We're not sure which. So one of these is 7, adding up to... Okay, yeah, these are 1 through 4, so these must be 4 through 7 then. To add up to 8. Right, this 9 could be 2, 7, could be 3, 6, 4, 5, or 4, 5, 2, 7, 3, 6, 4, 5. This is 7 here. So either this is 7 and this is 1. One thing these cannot be is 2, right? If we didn't explicitly say, but if you have 2, this has to be 1, 1, and 1, 1, which is not allowed. So one of these is a 1. That means... Yeah, and 4 is the most this can be along the digit, because you can't have 4, 5 here as the lowest. So 4 has to be the most. Therefore, one of these is 1. It must be with the 4. Therefore, this must be 5. So this is a 5, which means this can't be 5. Again, we know one of these is a 1. So since one of these is a 1, one of these two must be a 4. It could also have a 4 in here. We're not sure, but we know one of these two is a 4, definitely. So since one of these is 1, either this is 1, 2, and this would be 3, or this is 1, 3, and that would be 4. That doesn't really tell us much, but we do have that information. The other one cannot, obviously not be a 1. So one of these is 3 or 4. This could be 3 and this could be 4, but we don't know. We know, okay, we know one of these two cells must be the 7 in box 2, and therefore they're on column 4 and column 6. And the 7 in box 5 must also be in column 4 and column 6, which eliminates 7 from the rest of column 4 and column 6, because we have 2 cells which require 7 in both of those columns. Therefore, where is the 7 in box 8? It must be one of these 2 cells. I don't know how much that helps us, but... So if this is 7 and 2, this would then have to be the 7, and that would be with 1 there. Similarly, if this is 7 and that's 2, this would have to be the 7 and that would be 1. But either way, neither of these can be 2, right? So if this is 7, again, if this is 7, that forces this to be 7. This would have to be 2, this would have to be 1. This could no longer be 1 or 2. This would have to be 3 or 4. If this is the 7, this would have to be 7, this would be 2, this would have to be 1, this could no longer be 1 or 2. Therefore, we know then that this can never be 2, this can never be 2. Well, actually, that tells us a lot, actually. This can't be 2. Where is the 2 along this arrow? It must be here. So this is 2, which means these cannot be 2. This cannot be 2. So this specifically has to be 3, 5, or 6. But it cannot be 5, so therefore this must be 3 or 6, which means this can't be 3. This has to be a 1 or 4. If it's a 1, it has to be with 4. If it's a 4, it has to be with 1. Therefore, this is also 1 and 4. This could still be a 3. This can no longer be 3 then, because if this were 3, and this can't be 2, we now have a 1, 4, 1, 4 pair here. This can no longer be 3 then. This is 1 or 4 also. Therefore, this must be a 3, which means this is 4 or 7, because it must be 3 added up with 1 and 7 added up with 3. This can no longer be 3 along this column. We have a 1, 2, 3, 4 quadruple in row 8, which means the rest of the cells are 5 through 9. So this is 5 through 9, this is 5 through 9. This has to be 6 or 7 specifically, because it can't be 8, 5, 8, or 9. This is 5 through 9, and this is 5 through 9. Let's not use this. Let's just get the 6, 7. That is the clear one that is useful. Let's see. So whatever this cell is, let's make it red. And this cell must be the opposite. These two cells must add up to 5. So this cannot be 1 and 1. It cannot be the same cell. So this can't be red. This has to be blue, and this has to be red. I'm not sure what that tells us. Red then has to be one of those 3 cells. Blue has to be one of those 2 cells. Okay. So this is 1 or 4, which means this has to be 4 and 7. And this has to be 4 and 7. Aha. So now we have a 4, 7, 4, 7 pair in row 6 and in box 5, which eliminates 4 and 7, because these has to be 4 and 7 to add up with 1 or 4 to add up to 8. So therefore, there's no 4, 7 in the remaining cells in box 5 or in the remaining cells in row 6. So this can't be 4, this can't be 4. These can't be 4. We could remove the outer layer. Therefore, since these can't be 4, these can no longer be 4 either to add up to 8. We know a 4 has to be in one of the boxes, similarly to the 7s. The 4 has to be in one of the boxes, or one of the columns 4 and 6 for box 8. one of the 4s has to be in column 4 or 6 in box 5, which eliminates 4 and 4 from the rest of the cells in column 4 and column 6. So therefore, this cannot be 4. We knew this couldn't be 4. This can't be 4. So neither of these can be 5 then. So this not being a 4 means neither of these can be a 5 either. Well, this is 2 or 3. This can no longer be 5 because it would have to add up with a 4 to add up to 9. But that can't be the case. Therefore, this can no longer be 5. Where is the 5 along this arrow? It must be here. So this is a 5, which adds up with 2 or 3 to add up to 7 or 8. So this is 7 or 8. These can no longer be 5. This can no longer be 1 and 2 added together. So this can't be 3. This could be 1 or 3. That's possible still. This now must be 5 and 6 to add up to 8. So it can never be 3. This can't be... This could be 2, cannot be 3 here. We know one of these is 7, so one of these must be a 2. And the 2 must add up with 6 then. So one of these is a 2. One of these must be a 6 then, to add up to 8 with the 2. And then we have either a 6 and a 2, or a 3 and a 5. I'm not sure which. Either way, this can't be a 6 anymore. It couldn't be a 6 anyways, because that would be 2 plus 6 at most to add up to 8, which is not possible. Sorry, the 2 would be least, and the 6 would be there. This could be a 6 still, because that could be 6 and 1, adding up to 7. Hmm. So one of these cells is the same as the other one, right? We're not sure which, and it would be both 4s. Hmm. Right, so say, again, this was a 7, right? Then this would be 2, this would have to be 6. This could not be 7, so it would be 4 and 4. Which would make this a 7, this would be 1. This could be 2 or 5, this could be 3 or 6, either one works. Oh, wait. Can this ever actually be a 6? If this were a 6, this would have to be 2 and 7. But this 6 would be with 2, so that would be 8. Oh, that could work, actually. Can this ever be 2 is the question. Yeah, probably. Actually, let's work through that. What happens? So if this is 7, this is 2, this is 6, this is 4, this is 7, this is 4, this is 1, this is 4, this is 1. Say this was a 6. If this was 6, this was 2. This would have to be 3 with it, and this would be 2. Therefore, this would have to be a 7. This would be 1, this would be 6, this would be 4. So that does actually work. So far, that's looking kosher. What if this were 7? And this would be 2. This would have to be 3. This would be 6. This would be 5. This would be 6. This would be 4. 7. This is 4. This is 1. This is 4. This is 1. One of these must be 1, so it must be 1 here. So this would be 5 then. But then this would be 3, and that would break. Okay, so we've just shown that this doesn't work this way, right? If we tried to make the 7 here and this is 2, the problem is that this becomes a 4. So one of these has to be 1. It cannot be the 2 and 1 because 4 is already greater than it. So this would have to be 4 and 1, which would add up to 5. But then this would be 2. And this would have to have a 3, which it can't because of that 3. Therefore, this can never be 7. This can never be 7. Therefore, this is the 7, which makes this a 2, which makes this 7. This has to be 6 to add up to 8. This can never be 7, so this is 4. This is 7, which makes it adds up with 1 to add up to 8. This must be 4. This must be 1. This must be 4. Since we have a 1 here, one of these must be 1. And therefore, it cannot be 2 and 1 here. Therefore, this must be 4 and 1. And this must be 2 and 3 to add up to 5. This is 4 and 2 adding up to 6. 1 and 3 adding up to 4. So this cannot be 4, and it cannot be 5. This has to be, cannot be 6. This cannot be 2. Well, where is the 2 on this arrow? It must be here. So this is 2, which adds up with 3 to make 5, or 6 to make 8. So this is 5 or 8. This can no longer be 2. Now, what's the minimum this could add up to? Actually, wait, I don't know why I deleted the 1s here. This could still have a 1. Okay, this could still have a 1. This cannot be 1, though. So this could have a 1. Again, there has to be a 1 along one of the line segments in the arrows. It cannot be 1, 2, because this is already greater than 3. So therefore, this must be the 1, which means this must be 3 to add up to 5. 4 and 1 add up to 5. This adds up to 6. This must be 4. This can't be 4 or 5. This can no longer be 2. Therefore, this must be 2, and this must add up to 5 or 8 with the 3 or 6. This can't be 2 anymore. This can't be 4. What does this have to be? It cannot be 3, because this can't add up to 3. It cannot be 6, because this never adds up to 6. Can it be 3, 3? Can't be 6 and 0. Therefore, this must be a 7. So this must be a 7, which makes that a 6. This can't be 5, but it could be 1, 6, or 3, 4. We're not sure which. This can't be 6, obviously, so this is 2 or 5. What else do we have? This is 7 is the highest. That works. I think we have all the arrows set, essentially. Yeah. 5 cannot be here. 4 has to be one of these 2 cells. What can remaining cells be here? Cannot be 2, 5, 7, 8, or 9. It could be 1, 3, 4, or 6, though. So where's the last 7 in row 3? It cannot be here. So it has to be here because it can't be either of these because of the 7s that are already there. One of these 2 cells is a 7 because of these 2 7s here, which eliminates 7s here. This can't be 7. This cannot be 1, 2, 3, or 5, and it cannot be 7 or 8. So this has to be 4, 6, or 9. This cannot be 2, 3, 6, 7, or 5, but it could be 1, no 2, 3, could be 4, could not be 5, 6, 7, 8. So it could be 9. This can't be 1. One of these two is a 1, and this one can't be 1, so this must be the 1. Therefore, one of these two is a 1. 1 cannot be here. 1 is one of those 4. 2's. 2 has to be one of these two. And it has to be one of these two. Cannot be here or here, so it's one of these two. Okay. What about 3? Do we have very much for 3? No, not really. This is 3 and 6. They both eliminate 3 and 6 in this cell and these cells. So none of these cells can be 3 or 6. They can't be 7 or 9 either. And it can't be 2. So it's 1, 4, 5. No 2, no 3 or 6. It can't be 7. It could be 8. Cannot be 9. So this can't be 8 specifically, this can't be 1 or 4 specifically, and this can't be 4 specifically. Similarly, these two cells can never have a 3 or 6. It could be 1, cannot be 2, could not be 3, could be 4, no 5, cannot be 6, 7. It has to be 8 or 9, possibly. This can't be 4. By this 4, and this can't be 1. Okay, because we know both of these add up to 9, and it has to be either 3 here, and this is 6, or this is 6, and that's 3. That's the reason why we could eliminate 3 and 6 from these 3 cells, and 3 and 6 from these 2 cells. So 2 is the lowest here, 1 is the lowest here, obviously 3 is the highest, 2 is the lowest, 1 is the lowest, 5 is the highest. Yeah, the arrows are all done. What else do we have? It's probably just now Sudoku rules. What's the remaining cells here? In column 2. It has to be 4, 6, 7, 8, 9. So this is 4, 6, 7, 8, 9. It cannot be 7 or 9. This is 4, 6, no 7, 8, or 9. So 7 has to be one of these two cells here. Aha. So 7 is one of these two cells because it can't be in any of the remaining cells in column 2. Therefore, where is the 7 in column 3? Cannot be any of these cells because it's eliminated by those two. And it can't be this one. Cannot be these two because of these 7s. Therefore, this is the 7. Okay. This then has to be what? No 6. It could be 4, 7, 8, or 9, but can't be 4 either. So it's 7, 8, or 9. This is 7, 8, or 9. We have 4 digits here. What we're looking for is 2, 3, 5, 8, 9. So this could be 2, 3, 5, and 8. This could be 2, 3, or 9. This could be 2, 3, no 5, 8, or 9. And this is 2, 3, 8, or 9. We have 5 through 9 here. This can't be 5, 6, or 7. This is 8 or 9. Aha! And now we have a 7, 8, 9 triplet in box 7, which eliminates 7, 8, and 9 from the rest of the box, which leaves 3 and 5 remaining. This can't be 3, therefore this must be a 5, which makes this a 3. So the 7 has to be one of those two. This is 8 or 9. This has to then be 6, 7, 8, or 9. This is 6, 7, 8, or 9. So that works for that. But this can't be 7. Okay, well, no, that's not true. Okay, never mind. I was going to say, where's the 4, but it can't be there. So this is one of these two is a 3. Aha. So one of these two is a 3. We know then the 3 has to be one of these two remaining cells. Because 3 can never be here anymore. Well, because of this 3 also. And these can't be 3 because of the 3, 6 pair that we eliminated these possibilities from being 3. This can't be 6. So this could be 6, this could be 6, or this could be 6. We're not sure which. We have 4 digits along here, so let's see what these remaining digits are. It's 2, 3, 5, 8, and 9. This cannot be 3, but it could be 2, 8, or 9. This cannot be 2. Oh, let's do these remaining digits. It has to be 3, 6, 8, and 9. Right? These cannot be 3. So it's 6, 8, or 9 here. This can't be 8. This can't be 6. This is 3, 6, 8, or 9, but this can't be 9. Okay. The remaining digits here are, again, 2, 3, 8, 2, 3, 5, 8, 9. This can't be 5. Oh, this can't be 5. This can't be 5. Where is the last remaining 5 in box 5? It has to be here. So this is a 5, which forces this to be 3, which makes this a 6. So this cannot be 3 anymore. Okay, that should help. This can't be 6. 3 must be one of these two cells, and it can't be this one because of this 3. Therefore, this must be a 3. This has to be, this can't be a 5. Where's the last 5 in row 6? It has to be here. So this is a 5, which makes this 2, 8, or 9. Cannot be 8 or 9. Therefore, this is a 2, which means this can't be 2. We now have an 8, 9, 8, 9 pair in a lot of places. It's box 4, so the rest of the box 4 cannot contain 8 or 9. So this can't be 9. This is a 6 then. This can't be 6 or 9, so this is a 4. We already knew this was 9 or 9. So this can't be 9. This can't be 4. Therefore, this is 1. This has to be 4 then. So this is 3 and 4. We have 2, 3, and 9 remaining. So this cannot be 2, cannot be 9, because one of these two must be 9. And this can't be 3 because of that 3. Therefore, this must be 2, which means this is a 3, 9, 3, 9 pair. This has to be a 1 because that's the only digit remaining. These have to be 8 and 9. This can't be 1. Neither of these could be 1. What else do we have remaining? This can't be 6. Neither of these can be 6. These can't be 4. We now have a 3, 6, 8, and 9 quadruple in box 1, which eliminates 3 and 6 from the rest of the box. Therefore, this is only 1 of 4. One, where is 1 in box 3? It can't be these cells because of these ones. Therefore, it must be one of these two cells. Well, we now have a 1 that has to be in rows 2 and 3 for box 1. And we have another 1 that has to be in rows 2 and 3 in box 3, which eliminates 1 from the rest of the cells in rows 2 and 3. So this can't be 1. Where can the 1 be in column 6? It can only be here now. So therefore, this is a 1. That forces this to be a 2, which means neither of these can be 2. This can't be a 3. We now have a 3, 8, 9 triplet in column 4, which eliminates 3, 8, and 9 from the rest of the column. So this is 5. This can't be 5. This must be 4, which makes that a 3. That makes that an 8. This can no longer be 8. This can't be 4, so this must be 1, which makes that a 4. This can't be 1. Therefore, this must be a 1 here. This can't be 3 anymore. So we have an 8, 9, 8, 9 pair, which makes this a 3. This has to be 6 or 7, because those are the only digits remaining in column 5. Here must be 2, 3, and 9. So this is 2, 3, or 9, but it can't be 3 here. This is 2, 3, or 9. That's fine. This can no longer be the 2. So where's the last remaining 2? It has to be in box 8. It has to be here. which means this can't be 2. This is a 9, which makes that a 3, which makes that a 9. Therefore, that makes this a 2. This 9 makes that an 8, which makes that a 7 because it can't be 8 or 9. So this is 7. This can't be 8 or 9, so this must be a 3. This can't be 7 because of that 7, so this is a 6, which makes that a 7. This can no longer be 7. Where is the 7 in box 9? It's only here as possible, so this is 7. This can't be 7 again. This can't be 4. Where can the 4 be in column 7? It has to be here. And we have an 8, 9, 8, 9 pair in column 7, which eliminates 8 and 9 from the rest of the column. So this can't be 6. Or sorry, this is a 6. 2 and 3 add up to 5, so this is a 5. This can't be 6. We have an 8, 9, 8, 9 pair in column 9, which eliminates 8 and 9 from the rest of the column. So this must be a 6 then, because that's the only digit remaining, which makes this a 9, this an 8. This is 6. This is just a normal Sudoku now. This is 8. This is 9. This is 8. This is 9. This can't be an 8, so that forces this to be 9, which makes that 8, which makes that 9, which makes that 8. The only remaining digits now are 5, and this has to be 9, and therefore this has to be an 8. And that's how you solve it. Pretty cool, actually. I like the interactions between the arrows and how it forced certain things, and then the small clues above the arrows, which made things a little interesting. Yeah, pretty fun puzzle. And I hope you enjoyed this puzzle, and I'll see you next time on Frank Puzzles. Take care.